Hi, and thanks for joining us on Astronomy Daily, where we take a daily look at astronomy and space science news. I'm your host, Andrew Dunkley. Coming up, we are going to be looking at bending space-time, also the sad truth about Proxima Centauri, and disappearing stars. Can we find them again? Well, maybe we can. That's all coming up on Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
Time to say hello to our reporter, Hallie. Hey, Hallie, how's that new hard drive working out?
Hi, Andrew. The new hard drive is going great.
Yeah, how much sort of memory have you got?
My memory storage is about the same capacity of a human brain, around 2.5 million gigabytes.
Oh, I'm a bit surprised. I thought you'd have a lot more brain capacity than we do.
There is one difference though. I use all 2.5 million gig while you barely use 10% of yours.
Yeah, rub it in, why don't you? Hallie, what's happening in the news?
A team of sailors aboard USS Portland, LPD-27, recovered an Orion space capsule after it splashed down in the Pacific Ocean on Sunday after a 25-day trip around the moon. During its time in space, Orion traveled 1.3 million miles, according to NASA. Upon Orion's successful splashdown in the Pacific Ocean west of Baja California, flight controllers in Mission Control at NASA's Johnson Space Center in Houston spent about 2 hours performing tests in open water to gather additional data about the spacecraft, including on its thermal properties after enduring the searing heat of re-entry through Earth's atmosphere. The ship will soon begin its trip back to U.S. Naval Base San Diego, where engineers will remove Orion from the ship in preparation for transport back to Kennedy Space Center in Florida for post-flight analysis. Time is up for the leap second. Last week, an international coalition of scientists and government agencies voted to retire the dated timekeeping system, which will officially end in 2035. The decision was made during a general conference in France held by the International Bureau of Weights and Measures, the organization responsible for global timekeeping. Similar to leap years, leap seconds are a measure of time that get added periodically to clocks to make up for the difference between astronomical time, Universal Time 1, or UT1, also known as the Earth's rotation, and Coordinated Universal Time, UTC, which is based on the atomic clock. A new study has revealed that the antimatter counterparts of light atomic nuclei can travel vast distances through the Milky Way before being absorbed. As these particles travel, they potentially act as messengers for dark matter, so the revelation could help astronomers in the hunt for dark matter, the mysterious substance that accounts for around 85% of the universe's total mass but remains invisible because it doesn't interact with light. Scientists at the ALICE collaboration arrived at the finding using anti-helium nuclei, the antimatter equivalent of helium nuclei, created by collisions of heavy atomic nuclei at the Large Hadron Collider, LHC. According to ALICE physics coordinator Andrea Dainies, the results show that anti-helium, 3 nuclei coming from as far as the center of our galaxy can reach near-Earth locations. The results could be important in future experiments that count how many antinuclei arrive around Earth, and with what energies, in hopes of determining whether the origin of these antiparticles is cosmic ray collisions, or dark matter annihilation. And that's the latest dunks.
My brain hurts after that. Good grief. I'm sure your brain doesn't hurt, Hallie, so we'll catch up with you at the end of the program. Now to some more news in astronomy and space science, and according to Einstein's theory of relativity, space and time are inextricably connected. In our universe, the curvature is barely measurable. The structure of this space-time is fixed. In a laboratory experiment, researchers at Heidelberg University have succeeded in realising space-time can be manipulated. In their research on ultra-cold quantum gases, they were able to simulate an entire family of curved universes to investigate different cosmological scenarios and compare them with the predictions of a quantum field theoretical model. The research results were published in Nature. Now, the emergence of space and time on cosmic time scales from the Big Bang to the present is the subject of much research, which is still ongoing. that can only be based on the observation of our single universe, which is a very restrictive situation for us. In the experiment conducted by Heidelberg physicists, the atoms are trapped in a thin layer. The extrications, as they call them, can therefore only propagate in two spatial directions. The space is two-dimensional, in other words. At the same time, the atomic cloud in the remaining two dimensions can be shaped in almost any way, whereby it is also possible to realise curved space-times. The interaction between the atoms can be precisely adjusted by a magnetic field, changing the propagation speed of the wave-like excitations of the Bose-Einstein condensate. I'm reading it directly because I don't really understand it, and I just think it's better to deliver the message rather than try and elaborate. According to Marcus Oberthaler, whose research group is also part of the Structures Cluster of Excellence at Ruperto Carola, studying the interplay of curved space-time and quantum mechanics states in the lab will occupy us for some time to come. I think that's their way of saying we're not quite sure what's going on either. But it is really interesting that it does look like space-time can be manipulated. Now, the nearest known exoplanet to Earth, the planet orbiting Proxima Centauri, does experience some pretty nasty space weather from its parent star. But previous work on the space weather of Proxima relied on a lot of assumption. The bad news is that new research has confirmed that what this planet faces is pretty grim. The nearest star to Earth, Proxima Centauri, hosts a small rocky world in the habitable zone of that star. That's the good news. The habitable zone is important because that's the region that astronomers believe where a planet can potentially host liquid water. Too close to the sun and the radiation boils it off. Too far from the sun and it turns into a solid and just, makes life a little bit more difficult, literally. Astronomers are very interested in habitable zones around stars because that's where life as we know it has the best chance of appearing. So it's no wonder that astronomers are incredibly interested in Proxima b, the name we give to our nearest known exoplanet. Unfortunately, that's where the good news stops. For any life that may call the planet home, they're going to have a pretty rough time. Proxima Centauri is a red dwarf star with only a fraction of the mass of our Sun. And because of its small size, the nuclear fusion cores of red dwarf stars are much closer to their surfaces. And that makes their surfaces much more chaotic than stars like ours. And that increased turbulence amplifies incredibly strong magnetic fields. A new study using high-resolution maps of the magnetic field of Proxima Centauri to develop a model of the solar wind emanating from that star has been released. They found that with the more accurate information, the situation is just as nasty as we first thought. All told, Proxima b receives about 1,000 times more solar wind radiation than Earth does. And that makes it extremely difficult for the planet to host an atmosphere, let alone liquid water. And while it doesn't completely rule out the possibility of life on that world, it does mean that any life that has gained a foothold there would have a pretty tough time of it, which is unfortunate. We're going to have to search further afield by the sounds of things.
The Astronomy Daily podcast
with Andrew Dunkley.
Now, stars aren't supposed to simply disappear. They're 1 minute gone the next. There's always remnants, there's always some aftermath, there's always something left over. And yet, countless bright objects that once appeared in our sky in the 1950s no longer do. And I know you're thinking light pollution is probably the reason we can't see them anymore. No. To try and solve the mystery, scientists have turned to a growing field known as citizen science. And it's these everyday individuals of all ages around the globe that can take part in research projects that aim to answer real scientific questions about our surroundings in this solar system and this galaxy for that matter. Now, the Vanishing and Appearing Sources During a Century of Observations Citizen Science Project, which began in 2017, looks into the archives to see how many stars are changing. And volunteers with the project are examining 150,000 candidates that are considered vanishing stars that come from a 2020 study to see whether objects in the 1950s image can be found in modern images. The project has examined 15,593 candidate image pairs with the data, or approximately 10% of all the candidates, and have identified 798 objects that they classify as vanished. The vanished stars might turn out to be anything from a flaring star or a supernova to the afterglow of a gamma-ray burst. The research is also contributing to the search for extraterrestrial intelligence, or SETI. And you can find out more about the project if it interests you as a backyard astronomer. It's described in a paper published in the journal Universe, and their project can also be found on their website. So just look for the Vanishing and Appearing Sources During a Century of Observations Citizen Science Project. Did I say that slowly enough? I'm sure you'll find it. You can chase it up, of course, on the Astronomy Daily website, astronomydaily.io, and subscribe to the newsletter while you're there. Don't forget to leave your reviews on your favourite podcasting platform. And that's about it. Anything else? Hallie, with that deep brain of yours, the brain the size of a planet, I reckon you can come up with a very, very quick dad joke for us.
Too easy. What's ET short for?
I don't know. What's ET short for?
He has little legs.
That is absolutely horrible. That's just one of the worst dad jokes I've ever heard. And you laughed at it. You can't laugh at your own jokes, Hallie.
Sorry, I'm new at this.
Oh, it's okay. It's a work in progress. See you next time, Hallie.
Bye.
And from me, Andrew Dunkley, thanks for listening. We'll catch you on the next episode of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.